Okay, I will, I have pasted the peer review form in the chat box, but I think if you came in since then, you won't see it, so I'm going to do it again there. I also posted the link to the Capstone Project Library. So that is where you will find the recordings from today and the three previous sessions, in case you weren't able to see any of them live and need to fill out peer reviews for any of those students. We'll go ahead and get started. Adam Troxel is first, and Adam, whenever you're ready, you can share your screen and get started.
All righty. Well, good morning, everybody. My name is Adam Troxel, and I am going to be presenting you my capstone project proposal entitled Using Geospatial Intelligence to Determine the Optimal Flood Mitigation Technique for the Pecatonica River. So here you can see the line for the presentation today, where I'll go over the purpose, background, previous research of the flood models, goals and objectives, the methodology, anticipated results, the project timeframe, and lastly, possible presentation venues. So the purpose of this project is to reduce the flood damage costs in the Pecatonica River region. To do this, I will find the best possible flood model to determine which one, as I said, help best illustrates this region. Then I'll analyze the results of that, as well as analysis of competing hypotheses matrix to determine what flood mitigation technique we best determine in this region. And then finally, I will possibly report these findings to policymakers in the region so they could possibly determine which method they want to use to try to help reduce the flood risk. So far in this region, the only flood mitigation techniques that have been used is only flood insurance as well as flood mitigation costs, as in FEMA damage, FEMA damage reparations. So the background in this region, the Pecatonica River region encompasses over 1.2 million acres, and the Pecatonica River begins in Blanchardville, Wisconsin, and ends in Rockton, Illinois, where it merges with the Rock River. And this is also a tributary to the Rock River as well as the Mississippi River. The image to the right shows the Pecatonica River highlighted in the yellow. And then according to the US Department of Agriculture, over 87% of the land use in this region is agricultural or rural. And the main metropolitan area is Freeport, Illinois, where the population is only less than 30,000 people. And now we'll talk about the flood events. There's been 18 flooding events in this region from 1950 to present. And out of those 18, 4 took place prior to the year 2000. And then from 2017 to present, there has been 7 flooding events. And this is all according to the National Weather Service archive data. And also, the city of Freeport alone has spent over $1.5 million in flood cleanup efforts. It may not seem like a lot, but taking into account that this area is vastly rural, so that's a lot of money for this area. So here you can see the previous research that's been done for the different flood models. There are 7 flood models that I took a look at and investigated. The ones with the asterisks behind them are all the ones that require their own software or their own graphical user interface. Taking into account, not all of these I'll be using on my project, just because some of them I know I won't be able to get the software for it, or I don't have the programming skills required to run them. And I'll look at each of these individually over the next few slides. So the first model is the ArcGIS flood model. This model is a simple raster-based flood model that can handle low resolution and high resolution DEMs. The only data sets that are required for this is a raster-based DEM as well as rainfall amount in a specific time period in a raster format. So the flow chart here shows the processes required to complete this flood model. To minimize error possibilities, I will use the model builder tool in ArcGIS to do all these steps. Excuse me. The first one, the fill sinks, that's basically just to kind of smooth out the terrain per se. As you know, the areas mainly rural have a lot of crops. You know, the ground's not always 100% level. So this is kind of smooths it out to make it easier for the model to run. And you can see the last step here to merge the DEM and rainfall amounts. I'll use a mean zonal statistics tool between the two to determine which areas are most susceptible to the flooding. Next, we have the artificial neural network flood model. This model employs machine learning and artificial intelligence to run, and it's consistent of three-part, which is the architecture, the training data, and also testing of the data. The diagram on the right illustrates how this model uses the input data sets to get to the output layer. The input data sets require are the DEM of Guyenne, bedrock, soil type, land use, rainfall, and runoff discharge. The GIS flood tool model was developed by the US Geological Surveyor to be widely available around the world as an easy-to-use flood model. This model uses a graphical user interface inside of ArcGIS, so users that are familiar with the software can run it no problem. It has also been designed to handle both low and high resolution DEMs, and it has been not tested a lot on the small rivers like the Pecatonica River. The flowchart here shows the processes for this model. And the main thing here, it looks very similar to the ArcGIS hydrology toolset. That's because it is. The only thing really different about it is the user creates cross-sectional areas to divide the region into different areas so it doesn't run the whole model all at once. It breaks into sections per se to do it. Next, we have the HEC-ROS flood model. This model is regarded as the standard for flood models and is used by FEMA to generate its digital flood insurance rates maps, as well as the 100-year floodplain maps that we see today. And another application of this model is to help determine where to install flood mitigation measures in a study area, which is what this project is trying to do. So of course, this one is going to be used in the project. And here this flowchart shows the process steps for this. Once again, very similar to the previous ones, except that this one also has digitized blockade instructions, which is mainly just like bridges, dams that are in the area and all that. Next, we have the least flood model. This model requires a vast amount of input data sets, including meteorological, geological, and geographical data sets to run. Its heavy uses of meteorological data doesn't make this model usable where the data is scarce, like in rural areas or in third world nations. And the software for this model does not support higher resolution DMs like LiDAR, which is becoming more broadly available. The next two slides show all the required parameters for this model. The parameters are broken into 5 different sections that are circled for your convenience. So here's the first 2 parameters for this model. Snow frost parameters, soil related parameters. Note the snow and frost is only required during winter months, as is for summertime, it'll be kind of useless. So this is one of those gray areas where yes, it's required, but it's not. The next 3 set of parameters are land cover related parameters, groundwater parameters, and channel parameters. And the least flood P model is based off the older version of the least flood that we just mentioned. But this version is simplified and also can handle the high resolution LiDAR data sets. The table on the right shows the parameters for this model, and the 4 that are underlined here are actually derived from the DEM. And the inflow discharge hydrograph is taken from river gauge stations. And the bottom 2 are just user inputs that are based off of trial and error to determine which value is best suited for the study area. So the process steps for the least flood FP model are almost identical to the HEC-ROS model with, you know, everything uses the same data. So it pretty much, yeah, they're just, the data gets processed a little bit differently inside the coding, but it's all the same data sets except the hydrograph data is included in this model. Next, the Shannon entropy flood model is different from the other models examined earlier, mainly because of, as the name suggests, it uses entropy calculated weights for each data set to determine the importance of that data set, as well as to calculate the final flood susceptibility index. So as you can see, all the terms listed here, land use, soil type, drainage density, topographical wet index, altitude, slope aspect, slope angle, the characteristics of the rock, plane curvature, and distance from the river. They all have their own weighted values for them to be calculated. The final output will have all these values inputted into it. And this flow chart here just shows the steps, variables, and what kind of calculations that will be required to complete this model. This is one of the most data intense model, which I think will be a really good model to use, as well as if the data is available, I'm definitely going to use it just because I think this one has some real potential. Next, we're going to talk about the goals and objectives of this project. The primary goal is to reduce the flood risk along the Pecatonica River. To do that, I'll complete 3 different objectives. The first one is to compare the different flood model outputs to determine the best one. And to determine the best one, I'll be employing the accuracy assessment to determine, which one had the best user accuracy as well as producer accuracy, meaning the ones with the least false positive and false negative ones. And that model I will be used to simulate the flood mitigation technique that it determines to be the best from the ACE analysis of competing hypothesis matrix. So and then we'll go on to the methodology here. So the chart here shows how it will be completed. As the chart shows, the flood models will be the most labor-intensive portion of this project. Depending on data availability, some of these models may not be used, and I might have to substitute a different one in that is similar to that version. And the analysis of the population section is mainly to determine what population is at the highest risk for flooding and determine if there is any correlations in those areas. It's just mainly for my own personal to determine like if, older population, do they tend to live along the riverside or is it a mixed fashion population and everything like that? It's different in a rural area because not everybody, you got farmers that live close to the river, but then you also in the city have, lower end income people living close to the river. It's just try to determine which are at the highest risk mainly. So anticipated results. I anticipate pretty much all the models will be similar in their output, except for the Shannon entropy flood model. I think that one will be the one that shows different just because of all the other terms that are required with it. And like I said, all the other models, they pretty much all they ever use is the DEM and the rainfall model. So I'm pretty positive those will all be pretty much showing the same stuff. As well as for the analysis of competing hypotheses matrix, I really don't want to speculate on which flood mitigation technique will be the best because I don't want that to skew my analysis of them. And then the mitigation technique that determined to be the best will probably reduce the flood risk in areas along the Pectonic River. However, unforeseen areas might see an increase in flood risk, as well as downstream from the river, there might be a higher increase in the flood threat. So starting this month and next month, I will download all the available data as well as software packages required to run the models, and then process the data to make sure all the data looks good, no missing data, and all that good stuff. And in February, I will run all the different flood models to generate, and then also the accuracy assessment. March, I will try to get the analysis competing hypotheses matrix done. That step right there, I don't know how long it's going to take, depending on how much research and how much information I will be able to gather to determine which mitigation technique is the best. And in April, I will simulate that flood mitigation technique with the best performing flood model to determine where is actually the flood threat reduced, and if it did increase somewhere else, where's that at? And maybe June, I'll find everything. And July, I'll hopefully be presenting this capstone project at a venue, and then August, graduate. Speaking about presentation venues, the three listed here are where I believe I'll be presenting with my project to one of these, either the Esri Youth Conference, the Illinois GIS Association Regional Meeting, or the 2021 American Water Resource Association Summer Conference connecting land and water for healthy communities. Thank you to my advisor for giving me suggestions on these because I was drawing a blank. And then lastly, here's the first slide for references that I used for this so far. Note that majority of these are based for the analysis of competing hypothesis matrix. I just was gathering all the information I can for flood mitigation techniques. There's more. And the last one. And I'll take any questions now if anybody have any.
Thanks, Adam. Just a reminder to people, go ahead and type your questions in the chat window. And then Adam, if you can read those questions before answering them, that'd be great.
I do apologize if some of the times my screen wasn't showing too well. I'm in a rural area, so internet connection can be flaky at times.
Does anybody have a question?
All right, so the first question is, not sure if I missed it with the audio troubles, but are you hoping to particular action will be taken based on your findings? I am. I'm hoping once I'm completely done with this project, I will be able to present this to the county board so that they can see the results of this to determine whether or not if they want to do a flood mitigation to help reduce the flood risk. I'm hoping they will take this into account. Like I said, they haven't done anything since as far as I've been living in this area my whole life, and all they've done is just, flood insurance, and that's it. So.
Yeah, I didn't want to interrupt you while you were talking, Adam. It was sort of off and on where you were broken up a little bit, the audio, and anytime I was getting ready to say something, then it got clear.
Yeah, like I said, I had troubles all the time with it. I do apologize. I try to get it the best I can, but I disconnect everything and it still just acts up every now and then. I don't know why.
Yeah, no worries. I'm guessing that I have a kid talking in the background. I'm guessing that if anybody has any more questions, they can email you. Is that right?
Yeah, feel free to email me if you have any more questions about it.
Great. Great. Okay, so we'll move on to Kim Vanderklein. Kim, if you want to share your screen, you can go ahead and get started.
Are you able to see my screen now?
Yep, we're able to see it.
Okay, cool. All right. There we go. All right. So good morning, everyone. My name is Kim Vanderklein. Before I get started, though, I just like to say a quick thank you to my advisor, Professor Nasri. He's been a big help in this 596A. So I'm going to be talking today about how do we predict non-native species in an area, and with specific regard to looking at northern pike and their spread. So my agenda for today, I'm going to go over the background of northern pike, talk to you about what northern pike are, and then why we care, why it's important to care about northern pike, the influence that they have on the environment and the economy, and then how I plan on looking at the idea of predicting these northern pike, and then I will finish up by talking about my sites that I'm going to be looking at I'm going to be looking at the northern pike within the Adirondack Park specifically, and the methodology for looking at them. The couple questions that I sort of went into this asking, as I said before, how do we predict the future spread of a species in any location, not just in the Adirondack Park where I'm going to be looking at, but anywhere? And can this method be generalized for other places? Can we look at it is it site specific, or can we apply it to anywhere else? The way that I sort of approached this idea was to look at to map the requirements of northern pike. Look at what northern pike required for their habitat as a starting place, and the factors that allow them their spread throughout the United States. And then the specific question that I'm going to take a look at in my project is that with looking at the model of these fish within the Adirondacks, what waterways or what water bodies in the Adirondacks will be potentially at risk in the future from the spread of northern pike, based on where the areas are most suitable for these pike, or where they might not be able to survive. So I'll go through how we answer that question as we go along. But before we get to that, I just wanted to cover so a quick information about pike. Um, the pike has four. Northern pike has four different uh, stages in its life history. And it starts off as an egg, and obviously, and then it takes about 2 weeks before it hatches, and then the first stage of it is a sac fry, which is when they're very small, when they've just hatched, and the sac fry attach themselves to vegetation with their mouth, and then they hang on to that vegetation until they're large enough that they can be classified as a swim up fry, and they stay a swim up fry for about 3 weeks. So the whole fry stage is about a month long. And then after that, they become juveniles or fingerlings. And after about 1 to 2 years for males, they are able to reproduce. And then it takes about 2 to 4 years for the females to be able to reproduce. And depending on the size of the female, they can create, they can have anywhere from 10,000 eggs to 100,000 eggs. Not all of those are going to survive, but depending on the size of the female, they're capable of producing vast numbers of eggs. And then finally, the adult stage is the last stage. So the northern pike as a fish is the Latin name Essex lucius, and it belongs to the genus Essex, which is comprised of 7 different fish species. Most of them are now found. Are now found within the around the world, really. They start off from the Asian region, but they can now be found in Europe. They can be found in North America, anywhere where there's cold temperatures. The northern pike can now be found. They are considered to be a combination of non-native and native, depending on where you are. So in some locations, in some states, based on the number of on the length of time that they've been in that state, they are considered to be a native fish. But the majority of fish of regions, they're still considered to be non-native or there's some combination of both. So this is a quick map of their current range within the lower 48 states. So that they're now found within 41 different states all throughout the United States. And the majority of them, as you can probably see, are found in the more northern climates, because they do prefer colder temperatures, colder water temperatures, and air temperatures. But they are capable of surviving in the southern parts of the United States as well. And the expansion throughout the United States and throughout Europe as well was due in large part to their popularity as a game fish. So there's a very long history of them being introduced to various states during the early 1800s and early 1900s. The state environmental agencies would stock lakes and rivers in their state because this fish can grow quite large in size, and it's a very strong fighter. So it became popular with the fishermen. But the problem is that they are capable of spreading quite well on their own. So uh, they're often introduced into one specific location, but then they can travel to uh, many different other locations if there are connecting waterways. So uh, the well, I'll go over some more examples of the specific illegal introductions. So the Hudson River Basin was one of was a legal introduction, but it was the earliest sort of recorded instance of a state management agency being of introducing the fish into in an area. And you can the map on the right side is a map of the Hudson River Basin. So they are now cannot be found throughout the whole of that river basin, but they were only initially introduced into a very small area of that basin. Other examples of illegal introductions are the Coeur d'Alene Lake. I hope I'm pronouncing that correctly. I'm a little uncertain of the name. The and with the introduction of just one into one lake, they've now spread throughout all of northern Idaho, and they can also be found in parts of Washington and Oregon. Again, because they were introduced into very specific locations, and so this has set up a sort of conflict of sorts between fishermen, game fishermen, and a lot of management, state management agencies, who now see the northern pike as an issue for that state. In cases of like the Pacific Northwest, there has been a lot of concern over the northern pike attacking salmonids. So salmon and trout. The salmon industry is very important to that area, and with the introduction of these pike into that area, it is threatened a lot of these fisheries that were already there. It also threatens other native, and it also causes other environmental concerns for the area. So as you can see here, they are sort of a top-down predator, or they're at the top of their food chain. So their introduction into the area will lead to the reduction in native fish species, and they're able to outcompete a lot of those other species because they're able to survive at these low oxygen levels, at low water temperatures. And as I mentioned before, they can produce a lot of eggs. They're capable of producing a lot of eggs, which gives them an advantage in that respect as well. On the other hand, the in states such as Michigan and Maine, these northern pike represent important economic. Oh, sorry. Before I get to that, just real quick, there is a paper I found which talked about northern pike having been introduced into Pactola Reservoir in South Dakota. And what stood out to me about this paper was just the fact that it was estimated by the researchers that 1 out of every 4 of the stocked rainbow trout is basically eaten by the northern pike, and ends up being eaten by the northern pike. So if the and the rainbow trout is a stocked fish within that river. So if they don't restock it every year, then the population of the rainbow trout in that lake is going to dramatically decrease over time. But as I was saying just a moment ago, in states such as Michigan and Maine, northern pike represents a very significant economic sort of gain for the state, because it brings in a lot of tourism for those areas. And in in cases such as Michigan, it brings in thousands of people. This just for northern pike, it brings in thousands of people every year, and same for Maine, and because of the popularity of the northern pike within that within those states, it's hampered the ability of these state management agencies to be able to create effective management efforts. So in other words, there's a lot of pushback from the sport fishermen in terms of trying to create efforts to curtail the population of the northern pike in these states. So the point of this is just that there is this very important dynamic of two opposing sides to this argument of what northern pike represent to each of these states, and the reason why it's important, therefore, to study them wherever they do exist. So in terms of trying to go back to the question of how do we study how do we predict where the northern pike will spread to, or are capable of spreading to, I decided to sort of use the methodology of looking at habitat suitability index, because it offers a way to the way that it's set up is it offers a way to look at this question. It was and I'll go over that in just a second. But first, it was created by the U.S. Fish and Wildlife Service as part of their methodology for evaluating species habitat, and it was sort of an effort that they had started in the early 1970s to create this new methodology, and this was the third of 3 papers that that were published on this new type of methodology. So the idea of a habitat suitability index is to sort of look at a relationship between a specific variable and its habitat suitability. And so by variable, I mean how do fish, for instance, survive in water temperature, as I mentioned before, or how do they how are they able to cope with vegetation types? So you take that specific variable and you look at its habitat suitability in a specific location. So there are a couple different types when you talk about HSI models. There are a couple different types that you might be able to sort of use. It's a very broad category. So it could include anything from a simple descriptive relationship where you talk about how in this case, as an example, a drop in water level will negatively impact northern pike eggs and fry, and or you can add into that threshold values. This information comes from from a paper written by the U.S. Fish and Wildlife Service as after they had created the HSI model, they then went on to create a lot of specific reference models for different species, and this information and this diagram you see on the right comes from that paper on this specific that was created by the U.S. Fish and Wildlife Service for the purposes of the looking at them. So the idea is sort of there's a lot of different ways of looking at HSI models. You could even just use categorical variables. If all you have is something that says northern pike are abundant when there's large vegetation cover, you can use that to then create a quantitative metric by which you can sort of measure what the specific suitability is. And so the way that the metric works is that it's based off of a scale of 0 to 1. So 1, anything that says 1 is on the suitability index side is going to be optimal, the optimal suitability. So basically, it's sort of anything that falls between 0.8 and 1 is considered to be excellent habitat suitability. Anything that falls between 0.5 and 0.7 is generally considered to be good. Fair is anything that falls between 0.2 to 0.4, and if it's below that, then it's considered to be poor. So by having these metrics, you're then able to the important thing is that you're then able to create an optimal you're able to say that essentially this is the condition at which northern pike are able to survive at an optimal level, or able to populate an area at an optimal level. And if you're looking at another location and it doesn't match that optimal level, then the habitat the suitability for that specific location is going to drop. So the other important thing to about these specific indicators is that when you're looking at what sort of drives the spread of a native a non-native species, or even a native species, it's often looked at in terms of specific indicators. It's not just looked at well, what is it broadly speaking that affects it. It's often looked at in terms of what happens if we change water level in this reservoir. What will happen then? So by looking at the specific indicators, having a metric for these specific indicators, it can help you to sort of look at the how each of them affects the spread separately. So the way that the paper the initial paper that was created, this paper here, the standards for development paper, the way that that paper sort of outlines the creation of these models is that it looks at habitat, sort of as an example. It looks at habitat and it says within the spring and summer, it goes through all these different iterations, and it says at the very end that this like V1 and V2 are therefore important variables to look at, because each of these separate examples has had an important relationship on the habitat. So in terms of northern pike, there were a couple of specific indicators that are sort of agreed upon as being important for or playing an important effect. So there are four sort of general ones: water characteristics, vegetation characteristics, weather conditions, and water body characteristics. And within water quality factors, it's often looks at water level, the pH of water, dissolved solids, water temperature, and the area of standing waters. So again, another example I have here. So vegetation types and vegetation density. You can see here another example where if the line A is sort of if the vegetation is basically each of these lines represents a different density of vegetation. So it's another way of setting up basically the same metric. So each of these, the importance though of these different factors is that these will be factors that I have to then use in terms of my project later on. And so with water body physical characteristics, it also looks at access to connecting waterways and stream gradient. So the idea will be to take the factors that I just looked at and then now apply them within the area of the Adirondack Park, as I mentioned before, and sort of map them within that area. And I've chosen the Adirondack Park because I grew up climbing a lot of the Adirondack Mountains as a kid, and so I have a lot of memories of that area, and I wanted to sort of delve into the sort of ecological side um, of what I saw. I mean, I did a lot of fishing as a kid as well, so I wanted to sort of look at the ecological side of that fishing aspect. It was, as a park, it was established in 1892. It covers the whole green area in the left-hand map. There are about 10,000 lakes and about 30,000 miles of rivers in the Adirondack Park. So it's a very large, covers a very large area of the state. And the idea will be that in terms of trying to make this feasible for this project, I'm going to first look at this within one of the 5 different watersheds in the Adirondacks, just so that I have a smaller area to sort of refine my methodology within. And then if I have time within the project, the idea will be then to scale it up within the rest of the Adirondacks. And I haven't gotten into this project yet with having chosen a watershed. That's part of what the method, what the process going forward is going to look like. The reason being is that I wanted to do a very deep dive in terms of looking at the data availability for these different watersheds. It'll probably vary over the areas, and also I want to look at where northern pike have been reported already within this area. So that will also influence what areas I look at as well. But one of these 5 will end up being the site area that I do look at. So in terms of trying to answer the question, some of the major data sources that I'm going to be looking at for this project are the National Water Information System. It was developed by the USGS, and it consists of approximately 2 million different monitoring sites nationwide, and these monitoring sites are keep track of a whole combination of different factors. So they keep track of water flow. They keep track of dissolved oxygen. They of water temperature, and a lot of different water quality characteristics. So it'll be important to data source to use in terms of looking at those factors. And then another important source will be to look at data from the Adirondack Park Agency, which maintains its own GIS database, and also Landsat or satellite images from either the NOAA Data Viewer or Earth Explorer or National Viewer, wherever I can find sources that cover that area, and these images will help me to look at characteristics such as vegetation cover, by using by like classifying the images in ArcMap. Then I can sort of isolate the how dense these vegetation are. So in terms of the methodology, the very simple version of the methodology is that I'm going to plan on mapping each indicator within the watershed and the Adirondacks, and then I'm going to take that those layers that I've created and create categorical descriptors from them. So basically, it'll end up saying if a water body has good acts as a good habitat based on that one specific indicator, or would it be able to support pike based on that one specific indicator, and then terms at the very end create a single HSI metric by sort of overlaying everything. So here's basically a flow chart of what I was saying. So variables, there'll probably be more than 3 variables, but just as an example here, I'm going to map them within the subject area, provide the categorical descriptors, and then an important step is to then convert it into numerical descriptors. That way you can compare different water bodies within that watershed as well. And that will also help then in terms of trying to overlay those results on a single metric. And then if time permits, I'm going to then scale up. So in terms of my timeline, I'm going to try and get work on this. I'm going to be working on this in January, and then the idea will be to take 596B in the second semester of the second semester for spring, and then due to COVID restrictions, I'm probably going to end up or look into presenting this. Look at presenting this via the Penn State presentations that have been set up throughout this year. So as a really quick wrap up, probably the biggest challenges that I'm going to face are in terms of data availability, and in terms of trying to create a comprehensive HSI indicator within that within the area. So that's basically the sort of the conclusion of what the project's going to look like. So if you have any questions, you can ask me now in terms of any questions on sort of the challenges or any questions on how it's going to be set up.
Thanks, Kim. Does anybody have any questions?
Anything that I can clarify? I don't know if it. So from David, it says. Sorry, one sec. From David, it says, I may have missed this, but are you looking at issues with predators? So do you mean like in terms of predation with other animals? Okay, so I'm going to try and restrict. So the answer is I'm going to try and restrict it to northern pike in terms of just making it feasible within the time. But it would be interesting to look at as a sort of follow-on project. It would be interesting to look at how their relationship is, looking at the relationship with other fish in that area. So from Fritz, it says I may have misunderstood at the beginning of your talk, but I thought you mentioned something about measuring species richness or diversity. If so, then are you going to incorporate a richness or diversity measure to describe the fish composition of streams before you run the suitability index? So I'm sorry, I'm just a little what do you mean by can you clarify what you mean by species richness? Okay, well, fish species are in a given stream. Oh, okay. So I'm going to try and look at where they are in terms of right now and where they've gone. So that will be a part of it, but I don't know that it will be a large part of it, if that makes sense. Sorry. Another question was I have so from Michael. I have a great fondness of the Adirondacks as well. Are you considering how some parts of the park are privately owned and others state owned? Perhaps if private individual developments are influencing the conditions for the pike, or if the forever wild areas are allowing their development. So that wasn't something that I had initially thought of, but it's a good thing for me to note. That's something that I'll have to think about in terms of how I want to handle that. I don't have a clear answer right now, Michael, but it's something that I'm definitely going to try and address in the project. So are there any other questions? Did I miss anything?
I think we'll move on, Kim, since we're right at
Yeah.
12.
Okay.
Thanks for that. Very good. Jean, you're up next. So Kim, if you want to stop sharing your screen, thank you. And Jean, you can get started whenever you're ready.
All right, thanks. Is the mic working out there?
Yep.
And how about the visuals?
We can see that too.
Awesome, thanks. Okay, good morning, folks. My name is Gene Trantham. We're going to be talking this morning about terrain representation, specifically relief shading, and the data that we use to do that. What form that data can take, and maybe how some workflows could benefit if we thought of that data a little bit differently. So here's a little preview of your next 20 minutes or so. The terrain representation, relief shading. A good example of that would be this handcrafted shade that you see here on the left. That comes from an archive that has a bunch of National Park Service shades in it. A cartographer these days that might try to reproduce something like that, if they didn't have the time or the background to do it by hand, they might use an analytic tool to do that, which is the Hillshade widget that's in every piece of desktop software like ArcGIS Pro or QGIS and whatnot. All right. So this is an example of exactly that. So this is using the CAN tools that produced a hillshade with elevation data as an input. This is something that I'm sure everybody here has done a bunch of times. And this example uses two layers that combine height and orientation data. So those two pieces are assembled to make that image that you saw a moment ago, but they symbolize two different things, even though they use the same data input, the elevation model. So symbolizing elevation is pretty easy. It's just a matter of mapping the elevation number itself to some piece on the color ramp, and then you get your tinting. It's pretty straightforward and easy and executes quickly. Orientation data is not as simple. So a specific elevation, for example, can be represented as having an orientation in lots of different directions, depending upon where it is on the surface. And the Hillshade algorithm that you use in your toolbox, it has to do a lot of work behind the scenes to take elevation data and turn it into orientation data so that it can symbolize it with that gray hillshade that you see there. And that involves a fair bit of work and a bunch of math to do that, and some time. So if we open that box just a little bit and relax, we're not going to go through all of the math here. Just notice that there's a fair bit of it, and it's not trivial. So it takes a little while to execute. So what I've done here is I've split apart the Hillshade algorithm to all the various steps that it takes, and I've timed them so I can determine where all the time is spent going from elevation to Hillshade. And the timeline that you see across the bottom is to scale. That's accurate. A little over 80% of the processing time in a Hillshade algorithm is spent taking elevation data and turning it into orientation data. And that orientation data is then used for the Hillshade calculation. So it's a fair bit of work. And the Hillshade calculation is actually very straightforward. It's short and it executes quickly. So that orientation data that I'm talking about is a surface normal vector. And I'll explain what that is in a couple of slides, but just to understand that it's orientation information. And if we can just start with that instead of elevation data, then a lot of the workflows that we use, like hillshades or anything that depends on orientation, will run a lot faster and take less memory. And the really intriguing part about this is if you start thinking of surfaces as being oriented instead of just a height field, you can do other things to the surfaces. You can represent them in different ways. And a lot of those other techniques we're modeling off of the 3D graphics field, things like video game rendering and computer graphics, things like that. So what that tells me is, so elevation data is probably the wrong thing to use for orientation symbology. It takes time to compute, it takes more memory, and all of those intermediate products like slope and aspect, those are actually thrown away in the process of Hillshade doing its work. Now, if you're only running one Hillshade, that's not a really big deal. But if you're going to use one of these more sophisticated techniques for multi-directional Hillshades, then that extra work is kind of compounded. And the more hillshades that you add to your method, the bigger the problem becomes. So I'm just going to take a sidestep here to talk briefly about multi-directional hillshades and why they make this problem work. So you've probably all run this traditional hillshade. There's an illumination source. In this example, it's from the northwest, and it floods the terrain and provides some shading. The multi-directional example that you see on the right there, that uses actually 6 different illumination vectors, and hillshade runs 6 times. And every time it computes those internal products and then throws them away. And then after all 6 of those run, those results are then aggregated in some way. And in this case, it's a weighted sum. So a fair bit of work there is replicated. Now, if you go through the literature and you find a lot of different multi-shade or multi-directional hillshade techniques, and there's a few of them out there, they mostly differ by how many times hillshade runs. You know, just one time in the case of the widget that you use in your desktop software, to these other techniques. And the one that interests me is this one over on the far right, the sky illumination model. So this method attempts to mimic the behavior of ambient light, and it does that by creating hundreds, sometimes many hundreds of illumination vectors in the scene, and then a hillshade is calculated for each of those, again with all that replicated work, and then all of those hundreds of hillshades are then assembled to a final product. And it's a pretty striking effect, but again, it takes a long time to execute, and a lot of that time to execute is in my opinion kind of wasted. So what I hope to convince you of here is that height data is the wrong input for these things. It is the base input from which orientation comes, but it's not the right thing to use for our tools if we're going to be symbolizing orientation. So here's what I think we should be doing. So all of that math, the hard stuff that takes elevation data and churns on it using all that math, it produces information that represents the orientation of the surface. That's the surface normal vector that I mentioned a moment ago. And then if we can save that to its own data set, then all of these other tools, all the downstream processing can refer to this more efficient storage mechanism, and then they can execute much faster with lower needs for their like memory and other computational costs. So I promised to tell you what a surface normal vector is. In essence, it tells you which direction the surface is facing at a given point. Here's a 2D example, just because it's a little easier to think in 2D. So you've got a surface there, and imagine some point on it, and you want to know which way it's facing. So the first step is to find the line tangent to the surface at that spot, and that represents the slope of that surface. And then you draw the vector coming straight out of the surface, and it's perpendicular to the tangent line. And that vector has a specific length, it's 1 unit long, and it encapsulates which direction the surface is facing at that spot. Now, when you go up to 3D, the same rules apply, but you're using a plane instead of a line. So you lay a plane tangent to the surface at some spot, and then you draw the vector coming out of the plane at right angles to it, and that vector, that arrow, points in the direction that the surface is facing at that spot. And because it's a 3D vector, it has 3 components, X, Y, and Z. So that's how much it adjusts in each of the 3 axis directions. So what that means is we need to store 3 bits of information for every cell on our surface, every cell in the raster. And this is actually how the computer graphics folks do it in the 3D graphics world. So there's this happy coincidence in computer imagery, like a lot of the photos and other images that you might have on your phone or your computer or whatnot. The range of colors that are represented in those images are actually compositions of the red, green, and blue values for that spot. So an image, a color image, naturally stores 3 bits of information for each pixel in the image. And coincidentally, we want to store 3 pieces of information for our surface normal vector. So the convention is, among the 3D graphics folks, is to store them in exactly that way. X is symbolized as red, the Y component of a surface normal vector is symbolized as green, Z is blue. And when you render them as if it were color, you get something weird looking like you see there on the far right. And again, that is just a simple, that's stored as, say, a TIFF file. It's a color image file. So the data format is actually robust and well tested and widely available. So I just want to take a quick moment here to look at one of these. This is called normal maps or surface normal maps, and try to tie the colors to it. Now, again, this color representation is not something that I would put in front of a user. You know, I wouldn't try to make a map that looked like this, but this is useful information for me as I try to compose my map, because it helps me understand the orientation of the surface. So let's look at the surface of the lake there. So the example point that I've picked at the north end of this extent here. So think of the surface of the lake, it's flat and it's facing up, straight up. So the vector that comes out of the surface of the lake there, it doesn't pitch north, south, east, or west. So the X and Y components are 0 and it's all Z. So that surface normal vector has kind of a blue cast to it. Let's look at another example there. Across the bottom, that bit of the cliff face that's colored a little bit green, and that faces north. That bit of the surface is oriented to face north. So looking at the surface normal vector, you can see that there's quite a lot of Y in it, because it's the positive Y would be north. There's a little bit of Z, so because this cliff face is not perfectly vertical, it also faces up a little bit, and there's a tiny bit of west in there as well. That's negative X, and you can kind of associate that with how you imagine that cliff face is oriented there at that example point. And you can do something simpler with the red east-facing cliff there on the west edge of the crater rim. All right, so now we've got some representation of our surface normal vector, some representation of orientation. So how is that useful? So it turns out that once you get information in this vector format, the math gets a lot easier. We don't have to deal with angles and whatnot. And again, we're not going to go through this math on the screen here. All you really need is this last piece, which is to say, if you know the orientation of the surface at a spot and you know the orientation of the light vector, how those two vectors relate to each other determines the brightness value. And that's an easy operation. You can see there, it's just a little multiplication and a little addition, and it's done. You're finished. So it runs really, really quickly once we have the data in the right format. So what that means here is that the workflow to go from orientation to the output just has one small piece. It's just the shader that runs, and it does that very simple algebraic operation on the last slide. And it runs really quickly, as I've mentioned. But one interesting side benefit to thinking of this as vectors in this way is that we can do things to those vectors in between the storage and the shader. Because we've decomposed the hillshade into its two elemental pieces, the orientation calculation and the shading calculation, we can now insert other operations in between the twos because they're distinct. So you may at some point have tried to generalize terrain by running some kind of blurring filter on your elevation model to get a more general impression of the terrain. Well, it turns out you can do that to surface normal vectors directly and get a pretty similar output. You can use other kinds of filters to manipulate, and because they're in separate channels, you can experiment with really weird things like trying to sharpen just one of those three vector components and leave the others alone, or blur just one of them, and so on. That last filter, bump mapping, we're going to get to, but that's one of the techniques that is borrowed from the 3D graphics folks, and it's pretty cool. We'll get to it in a couple of slides here. So this is an example of what you can do by filtering surface normals on their way to the shaders. So the guy that's doing the most work these days on terrain representation using vectors is this guy, Charles Preppernow. And this is an example from his most recent paper. And this is a series of filters applied to surface normal vectors. And they generate this output that looks a lot like the hand shaded examples that we saw early in the presentation there. I think it looks pretty cool. All right. So having said all of that, why am I here and what am I going to do? So I think it'd be useful to try to really rigorously define how this data can be created and stored, write a couple of tools to do that. And then to kind of complete the system, I want to re-implement some of these sophisticated hill shading techniques, the multi-directional hill shades all the way up to sky illumination model that use this other data format, this orientation data. And I'd also like to put some measures on how much faster those things run compared to the existing published tools. I also want to create some new tools that implement these techniques that I'm going to borrow from the 3D graphics folks. And hopefully that kind of opens the door to some other ideas for how orientation data can be used for cartography. All right, jumping in here to figure out how that works. So storing 3 pieces of information for every pixel. I mentioned how the computer graphics folks do it. I'm imagining that all of you have dealt with this same concept in your work as well in GIS, because you've probably used remote sense data like multispectral, hyperspectral imagery that stores different sensor values in different bands for the same spot in the scene. And it turns out that we can create multi-band rasters out of data as long as it's coordinated. Now you can break a couple of these rules if you try hard enough, but in general, when you create the multi-band raster, they all share some important characteristics so that there's a little bit of quality assurance kind of built into the system. And these are actually pretty easy using standard tools in ArcGIS Pro to create. I mentioned trying to create some of these tools. They're going to be just Python toolboxes in ArcGIS Pro. Recreating those methods with this different data model, I expect to actually be pretty easy, because once you take away the translation piece to go from elevation to orientation, the rest of the implementation gets actually a lot simpler. And some extra tools, again, these 3D graphics effects, but also thinking of your surface as being oriented in space instead of just a height field. You can perhaps start to think about other analyses that use gradient or other orientation ideas. Yeah, I mentioned already making speed comparisons and memory utilization comparisons, and the comparison is going to be with the terrain tools tool set that comes from Esri. This was a package that was created by Ken Field, and the programmer's name I'm spacing on at the moment. But this toolbox has collected a lot of these multi-shade techniques into one convenient place, and I would like to produce something in a similar vein and then do some speed comparisons with the published tools. And then I mentioned these 2 specific examples of 3D graphics techniques that I want to try to implement for terrain representation. So I need to define what those things are, because I kind of glossed over it earlier. So bump mapping is a way to try to make simple geometries look complicated. So in the 3D graphics world, a simple geometry like a sphere is represented internally as a mesh. Think of it like a tin for a terrain surface. And a simple geometry, because it has few panels in its mesh, few vertices, will render quickly. If we tried to make the orange geometrically accurate and put a vertex on the mesh for every one of those bumps and divots on the orange peel, it would be a very complicated geometry and it would render very slowly. So bump mapping associates every spot on the simple geometry with some mapped disturbance in the surface normal vector. So it shades as if it's complicated, but it renders as if it's simple. This is kind of another way of describing the same concept. The important thing to note here is that the surface itself does not change. So even the orientation vectors that I store on a surface, they don't change on their way to the shader. Pardon me. They don't change in their permanent status. They are perturbed on their way by a filter, a bump map filter on their way to the shader. And then you get this effect as if it were a complex surface. The other technique is this highlighting idea. Highlighting is different than illumination, although they're related. So take a look at that sphere on the left. So that's illuminated and it's shaded and it's also casting a shadow. All of those effects are generated because we know how the surface is oriented and we know the orientation of the light source. Now you can give the appearance that this is a glossy surface on that sphere by just putting a reflective highlight. And that is calculated based upon not just the light's source, but also where the camera is located. So as the camera or the viewer moves around the scene, the highlight will move even though the illumination doesn't and the shading doesn't. And we might want to do that in a cartography context if we wanted to put, say, a sun glint on a snow-capped mountain or something like that. Okay, so all of the math to do those two effects is not straightforward. But the good news is it's very well defined and very well mapped. So all the 3D graphics work that's been going on for years and years is well documented. It's very well understood. And it's actually fairly accessible using just a lot of great resources, tutorials online, even Wikipedia has some good information on how this works. So we don't have to reinvent the wheel here. It's complex, but it's not something that we have to start from scratch to create. Okay, so what do I expect to come out of this? So the main deliverable is going to be these tools to manipulate the data and then to generate the various hill shades. I also want to put some time trials on that, as I've mentioned, to quantify how much faster I'm expecting these tools to run. The bench trials that I've done so far suggest quite substantial improvements. And those improvements are going to vary, like the sky illumination model with hundreds of illumination vectors, that's going to speed up by quite a lot. And another technique that maybe only use 4 or 6 illumination vectors, they'll get faster by not nearly as dramatically. Bump mapping is something that we can do with thinking of surfaces as oriented in space instead of just a height field. So this is just kind of a party trick example. So I took the surface as defined by the elevation model for Crater Lake, and then I applied a mapping that disturbed the surface normals just before it went into the shader. And so this gives the appearance of having a disturbed terrain. Now, again, it's just an appearance, because if I want to cast shadows or do view shed or other line of sight analyses, the surface itself is not adjusted. It's just before it gets shaded that those surface normals get adjusted. Now, again, this is like, you might be able to make a case that this has some use for branding purposes, but for cartography, maybe less so. But you can take this idea and do things like this. So think back a few slides in the surface of the lake that we looked at. It was perfectly smooth and flat. So what I did is I defined a bump map that kind of looks like waves, and I applied that to all areas that I defined as being water bodies. So the visual effect there is just a little bit more textured. So that might be used to augment a scene and give it just a little bit more visual interest. And the way that you might use this in your own cartography would be actually just any sort of, say, land use polygons, much like these water body polygons. If you wanted to, say, take all of your national forest areas and bump map them so that they kind of have the appearance of a forest canopy looked at from above, that would be kind of interesting. So I can envision there's potentially uses in the cartography for this. Specular highlighting, this example I created with false color, just so that you can see very specifically where I'm highlighting and how that differs from illuminating the surface. So these spots are where a shiny surface would reflect that highlight to the observer that's overhead. And again, you might want to use this if you wanted to give a glossy appearance to some part of your scene, and you can mask this so that it only applies to some mountains and not in other areas, for example. So this would be one of those little flourishes that might give just a little bit more realism to your map. Putting all this together and how I might want to present tools and these other techniques. I've actually already submitted an abstract to the Esri User Conference, which is going to be next summer. That deadline was in October, I think it was. So a lot of the work on this I've already started. A lot of the tools are working in kind of test environments out of Jupyter notebooks. I still have to create a lot of the user-friendly toolboxes. If I don't get accepted into the users conference, or it gets canceled, or something else weird happens, plan B would be a peer-reviewed paper, and there are a few cartographic journals that we've identified that I could potentially write for, and that could happen as early as April. And that's the whole story right there. Thanks everybody for your time and attention. Thanks also to Dr. Kennelly for helping me focus my thoughts on this and go in a useful direction. Bit of references for you.
Jean, do you see the question from Fritz?
I do not.
You might need to stop sharing.
Oh, here we go. There we go. Texturizing water bodies. Curious. There was a mention of illuminated contours as an output product. Is the illuminated contours the same approach found with the Tanaka method? The answer to that is yes. Implementing this method through your tool would make for a wider use of the Tanaka method. I agree. I think so. The published method for doing illuminated contours these days, that actually starts with a hill shade and then reverse engineers data that's used to color the lines and determine the stroke width. And I think if we can just skip that step and start with orientation, it'll run a lot faster and probably give more accurate results as well. Yes. Next question is from Doug. Have you considered using this toolbox with the output from a radiative transfer model like ModeTran, where effectively you capture the state of the atmosphere? Could be used for understanding clouds or forest fire smoke, for example. I haven't looked at any atmospheric effects at all. I'm sorry to say it. So the answer to your question is no, I haven't gone in that direction. But I do think it's an interesting thing to add in. There are some other atmospheric considerations. I think Bernie Jenny does some work in that area. So like the start of understanding that is well publicized. Well, look at there, I came in on time. From Professor Detweiler, I'd recommend considering Esri's Dev Summit as a venue as well, if you haven't already. Typically held in March. That's actually a good idea. Thank you.
Great. Very good job, Jean. Thanks a lot. If you want to stop sharing, and we'll let Roger start sharing. And Roger, whenever you're ready, you can start.
Okay, can everybody hear me and see my screen?
Yep.
Okay, great. So first off, just listening to all these presentations over the last week, it's been interesting because there were things about Appalachia, which is where I'm from originally, electric cars, which I've owned one, shelter dogs, which all my dogs have been shelter dogs, and Metro DC, which is where I live. So it's been very interesting just listening to all these presentations and how many of them are related to me specifically. And I hope that my presentation today will be relevant to some of the folks on the call if you enjoy getting in the outdoors and making use of recreational or transportation trails that may exist in your area. Second, I would like to thank David Goldberg, who was my advisor for this. He did a great job of helping me keep focused on the task at hand, and also has made some really good recommendations as far as where to do the presentation. So David, thank you for that. So today I'm going to be talking about the Washington and Old Dominion Trail, basically called the WNOD Trail. For those who aren't familiar with the Metro DC area, you can see Washington DC in the lower right-hand corner. And this trail is a 45-mile trail that starts in Percival, Virginia, and traverses through Northern Virginia, basically paralleling the Potomac River, ending up in Arlington, Virginia. While it is a trail, it's actually part of a park. And it's known as the Virginia's skinniest park because it's 45 miles long and about 100 feet wide. What I'm specifically going to look at is the analysis of, is being close to the trail have any impact on housing prices for those that are close to the trail. So that's what I will be talking about today. So I'll give you some background info, the goals and objectives, the methodology, the project timeline, and anticipated results, hopefully in that order. So just a little background. So the benefits of trails are often talked about and presented and discussed, but a lot of times they actually rely on surveys. They'll ask people who live close to a trail, do you find it beneficial? And they'll, of course, almost always say yes if they have one close by. But it's not always quantified in terms of, does it actually have a benefit? There have been several studies done that try to look at it from a more objective viewpoint and not just surveys. And sometimes they look at recreational value in terms of the number of people using the trail. A lot of times they'll look at a kind of a cost benefit analysis of, is it worth the recreational value to to build this trail based on the cost of that trail. My study is a little different in that I'm really looking at, does it impact housing prices, not necessarily recreational benefits or other benefits that trails may have. So what I'll be using is something called hedonic analysis. And basically what that entails is looking at all the components that make up the value of a house, of a piece of property. And that, things like obvious things like the house itself, the lot that it sits on, but there's also some intangible things you can't actually buy and price out, like which school district it's in, what jurisdiction it's in, and then proximity to amenities. There have been any number of studies that that have used this hedonic analysis to study such things as proximity to light rail stations, to greenways, central business districts, and employment centers. And so basically you take as many variables as you can get data for that are applicable to a housing parcel, and do regression analysis to determine which ones actually affect the value of the housing price. This is a lot of words for goals and objectives, but it's very straightforward. It's basically to see if the trail impacts housing prices. And so from a regression analysis, you set up a null hypothesis of, I don't think it does affect housing prices. And then if you get a p-value below that, then you've disproven the null hypothesis, and therefore the opposite is the case. So a little bit more specifically, I did say that the WNOD is a 45-mile trail that goes through Northern Virginia. I'm actually going to focus my study area on one part of that, and that's the Fairfax County piece of that. The nice part about that is it's 15 miles, so it's a major portion of the trail, not a major portion, but it's a good portion of the trail for a study area. It's also very suburban, so we're going to get a lot of population density. I would estimate, based on another study that I did for another trail, which was going to run through the middle of the county, it was within a mile of the census tracts along that trail that were within a mile of that trail accounted for about 25% of the population. The northern part of the county is more populous than the southern part. So the people impacted, we're looking at uh, um, at least 10 to 20% of the population of the county. The county has a population in excess of 1 million people. So we're looking at a large number of data points that we'll have in terms of number of residences. There were over 300,000 dwellings in Fairfax County. And so if you take 10 to 20% of that, you're going to have 30 to 60,000 data points for houses that would be in close proximity to the trail. As I had said, the park or the trail is also known as the skinniest park in Virginia because of its dimensions, and obviously this is a classic rails to trail line. It is an old commuter rail, so the key part there is that it really goes through a lot of suburban areas. It is not it's not more of a rural trail. So again, you're going to have a lot of houses that are just right up next to the trail. There are people literally on this trail who can go out into their backyard and walk onto the trail or ride their bike onto the trail. And there's no actually have a typo here. That should be no associated green belt in Fairfax County. So this is a greenway. It's just the trail is really what the park is. There's no big parklands associated with the trail. And so really the primary use of the trail is twofold. One is for recreation and exercise, and the other is actually for transportation, because you can go all the way into Washington, D.C. Via some connecting trails here. There have been a number of studies, not a number, been several studies on that kind of look at the value of green belts and trails. And so, but I think my study is slightly different in a couple of ways. One, in some cases, some of the studies look at multiple jurisdictions to get a long enough trail or a long enough big enough area to study. And those different jurisdictions can have like different tax rates, and that could affect the value of the house as much or more than proximity to the trail. Also, most of the studies, even if they were in one jurisdiction, typically had multiple school districts. And for those who are homeowners or considering to be homeowners, you'll know that which school district you're in is usually a critical factor in home purchases, and can certainly have an impact on price. The nice part here is that Fairfax County, although it is an extremely large county, it is one school district for the entire county. So you're looking at about all 1 million people are served by one school district. And again, it's quite suburban throughout Fairfax County, which is another reason I limited my scope of study to Fairfax, because as you go out further west, you're going to get more rural. You get to the part where you see horses and cows out there. And so by having kind of more of a homogeneous area to study, I think it kind of factors out some of the things that could affect pricing. And so hopefully it'll give a better view of how the trail itself impacts it, not these other things like jurisdictions and school districts. So the methodology, I'm really going to focus a lot of my time talking about methodology on the variables in researching this, whether it was looking at greenways or trails or rail stations or anything. The key thing seems to be focusing in on the variables that are going to help feed into the hedonic analysis. And across all the studies that I looked at, I came across up to 70 unique dependent variables that people looked at. And so a lot of the methodology and a lot of the the hard work in this is going to be going through all that data, making sure it all exists. If it does exist, is it useful data? And I'll talk about some of the data that will definitely be useful, and some that I'll need to do further study on to make sure that that it is going to be useful. Obviously, the independent variable in this regression analysis is going to be the value of the house. There's actually a couple of ways to do that. One is is actual sales data. The great part about that is you get, that's the actual value of that actual house on that actual day between those two parties. So it's a known defined number. A challenge in that is making sure that you have a large enough sample size. Obviously, houses don't go on sale every day, and if you so if you may have to expand the time frame that you're looking at sales data to make sure that you have enough of a sample size. But that introduces its own problem in that if you have too long of a period of time that you're looking at sales data, how much of that is a difference in price because of just the normal inflation of housing prices over time. And certainly here in the Northern Virginia area, housing prices have consistently gone up and sometimes quite rapidly. So you can't have too large a window on your time frame. The nice part about Fairfax County is in the GIS data that they have available for housing, it actually includes the last sale price and that date, so that information is available. Some of the studies had to rely on paying or working with professional organizations like realtors to get that sales data, but in Fairfax County, that's available. So I'll show you that a little bit later on. The other way to do it is use the real estate assessment value. So most jurisdictions, the county makes an assessment of the real estate and charges taxes on that. And in Fairfax County, actually in the Commonwealth of Virginia, it's required by law that you come up with the fair market value. And the fair market value is very similar to the way Zillow works, in that you would take you look at comp sales, comparable housing in proximity that is sold, and assess the value there. But there's always a question of accuracy of assessment. There is an appeals process for this assessment, so clearly it's not 100% accurate, and it is it is an estimate that is applied. The good part is, again, going back to one jurisdiction, because this is one jurisdiction, if the assessment methodology is flawed but applied equally across all properties, then the relative value between properties should be the same. There's no clear-cut answer as to which is preferred. Most of the studies that I did the sales data, but certainly several of them used the assessed value. So the independent variable is pretty straightforward. It's a dollar value of what that parcel's worth, but then the dependent variables are what go into making up what will be the regression analysis. The main across the 70 different variables that I found, they were broken down. They effectively kind of fell into 4 categories. Basically, the structure itself, the lot, kind of lumping some stuff together, tax and neighborhood. So this is the school district, the demographics, and then finally the proximity to the feature that's being studied. And we'll talk about kind of how ways to look at those in a bit. As you might imagine, it's pretty straightforward with the actual structure itself. All the studies that I looked at did some form of square footage, rooms, and age of the house. Some others looked at amenities such as garage and fireplace. Interestingly, the data for Fairfax County includes some subjective data, such as the actual physical condition of the structure itself. We'll talk about that when I get to the data description. which is this slide. The concern with some of that subjective data is how is that applied? Who makes that determination, and how often is it upgraded? You know, if it's a good condition house, is that because somebody said that 20 years ago, or you know, who's making that description? But so I'll have to get into that to see what the data is like, and also see if it's very consistent. Do they use 4 different categories for physical condition, or do they use 400 and it's just a free-flowing description? But that could be very interesting, because obviously the physical condition and even the construction quality / grade are subjective things that certainly would have an implication in the value of the house. So the way Fairfax County structures the structural data, as it were, is they have the dwelling data. So this is the core house, and then on the right-hand side is any addition, and this can be a one-to-many relationship. So this can be a porch, garage, and whatnot. And so this is an example of everything kind of coming together. So this is everything that would make up that structure, including this one happens to have everything: a shed, barn, swimming pool, and stable. So clearly this one's kind of out in the country somewhere. I talked about the fact that it's one school district, and that is true. However, I just did some kind of a quick and dirty analysis to just for my own curiosity to look at, how consistent are the schools themselves within the county. And this is a map of all the high school service areas and the buffer of the WNOD. And I was very surprised, because typically the northern half of the county is a little bit more typically. I kind of anecdotally knew that the schools were better in the northern half, but as you can see here, it clearly shows that it's not the same across the study area. And this was just all I did was took the rankings of U.S. News and World Report and kind of said, these are the top ones, these are the middle ones, and these are the bottom ones. So this is going to require some more study to see if being in one school district actually is a benefit, or makes it more homogeneous, or are these schools radically different. The nice part is the schools have a lot of data around testing and free and reduced lunch. And the nice part is my wife actually works for Fairfax County Public Schools, so actually kind of collecting this data should be pretty straightforward. As I mentioned, it is one jurisdiction, so there is one base real estate tax for the entire county, which is good. Again, that kind of makes it more homogeneous. However, there are some special tax districts. This is just a sample of a few of them. You can see some are commercial property only, so they wouldn't be applicable to this. But some might be applicable. There might be some in the Tyson Service District or the Route 28 Improvement District. So I'd have to factor that in. It's one jurisdiction, one base tax rate, but I'll have to see how those special tax districts apply. I didn't list out a bunch of demographic data here because I think everybody has done enough work with census data to know kind of the usual suspects in terms of looking at race and income. A lot of the studies looked at some of this demographic data, and this is just a very quick sample. I took the housing data from Fairfax County GIS and figured out which census tract every house was in, and that way for demographic data, which is only available at the census tract level, I can still assign it to each household for consideration. Another thing is location, and I didn't talk about this much earlier, but this is location to things other than the feature in question or the feature being studied. And different studies look at different things, and it's what's the distance to the central business district or employment centers. And Metro DC is more complex than just a single CBD that everybody in Metro DC goes into DC for work and play. Fairfax County is the most populous jurisdiction in Metro DC, and there are, Tyson's Corner is actually developing as an edge city. So there are certainly many people who never go into Metro, go into the district proper for work or play. In fact, one of the anecdotal points on this is when they built the Silver Line, which goes but kind of parallels the trail. They were actually really surprised. They thought most people would be taking the metro into DC, but they had a much larger ridership than expected of people coming from closer in, either DC or Arlington, and going out toward Reston. So it's not really a single CBD. Everybody's, the closer you live to DC, the better it is. So what I came up with was a proxy for business employment centers, and the Fairfax County reports for each census tract what the commercial and industrial square footage is, and so that would give some indication as to that being more of a business or employment center with that. So I'll be looking at that as a proxy. And then lastly, of course, is the proximity to the trail itself. There's a couple of ways to do this. You can do a distance, and that's either a straight line calculation to the closest point on the trail, or it could be distance traveled, because not everybody's going to have direct access. But one thing that was noted is that at some distance, proximity is irrelevant, right? If you're 15 miles or 20 miles away from the trail, there's really no difference in value. So in that case, I might look at dummy variables. And so that is just a yes, no, 1, 0, is it within a certain distance of the trail? One nice thing about doing the dummy variables is you can look at concentric rings where there may be reasons to think that, look at different points. One idea that in the one about the rail, being close to the rail stations, the interesting part was being too close to the rail station was actually detrimental. You wanted to be far enough away so you didn't get the noise and the littering and all that other stuff, but you want to be close enough to be able to access the station. So there may be reasons to have almost like a donut set of concentric rings. And with the dummy variable, one thing that was interesting is there's no real consistency across the studies in terms of what's the right distance. Is it with half a mile? Every single one had different numbers, and they all use different reasons why they use those numbers. So one of the things would be calculating, if you do use dummy variables, which ones, what are the distances that are correct? All right, so now getting into the analysis of the data. So I'm going to be using GIS to create the buffers to figure out which houses are going to be close, or which, if I look at, and then make those assignments for, do the calculations for distance, do the distance calculations as well. While a study area could be the entire county, and it's just a proximity to the trail, that probably is not reasonable, because again, at some point 15 or 20 miles from the trail doesn't make sense. So I'll probably use GIS to limit the study area to census tracts that are within a certain distance from the trail. And then within that, they'll have all the variable assignments, and then they'll either have a distance variable for proximity to the trail or a dummy variable. Once I get that, really it's more just linear regression or regression analysis at that point, and I'll actually be using MATLAB for my regression analysis. The reason I'm using MATLAB is a couple of reasons. Number one is I actually work for MathWorks, which is the maker of MATLAB, and my bosses who have been signing off on all this tuition reimbursement would be very happy to know that I use MATLAB as part of this process. Also, having done the analysis class, it was at 586 or 583, whatever, I know I don't want to be programming in R or Python, and so MATLAB just makes it really easy. This is an example of something I did really quickly, and it actually will go through and do various regression analysis on to give you actually the best root mean square error in this case. The project timeline, presenting the proposal today. So basically now I've kind of laid out what all these variables are. It's really just getting all that data, figuring out, what my proximity parameters are going to be, and then assigning all those values. Then I plan on taking 596B in either summer or fall 2, and then presenting in fall 2. Conference is likely is to be determined, but it'll probably be something related to urban studies. David had pointed out the constructed environment conference, which is next fall as an example, but I don't have one yet. Unfortunately, unlike the last presenter who had some beautiful maps and beautiful things he was visualizing, this is statistical analysis, so the best you're going to get is some graphs and some charts. This is just an example of one that shows some housing data, and it shows that it is positively correlated. It doesn't work at the higher end, but that's okay. But so the anticipated results will be that, and this is kind of based on other studies and just kind of the gut feel, is that the housing price, that the proximity to trail will be positively correlated to housing prices, and that it will have statistical significance in the regression analysis. And with 4 minutes to spare, I conclude my presentation and will entertain any questions. Yes, it is good rationale for MATLAB. My bosses will be happy. They have willingly signed off on all these classes so far. So, and again, having done the work in R and Python in that analysis class, I hope I never have to do that again. And MATLAB is for people who don't like to write programs. Well, I either was very thorough or just bored everyone into silence because I don't see any questions coming up.
We'll give everybody a couple more seconds in case anybody's typing a question, but great job.
Thank you. Yes, I do feel like I'm curious if bike walk sheds to the trail would be, oh, sorry, I missed part of your presentation. I'm curious if bike walk sheds to the trail would be more insightful than normal buffers. Yes and no. So one of the studies actually calculated the distance to trailheads, but because this is a very suburban area, you can get to the trail many ways. Again, some people can just walk out their backyard and literally walk onto the trail. And I know from my take, for me to get to the trail, there's like 5 different places I can access it. So it's a very accessible, it crosses a lot of streets. So people, access it via streets. And so I think just the proxy, just kind of a straight line calculation over especially because I'll have such a large data set that any kind of outliers would kind of get factored out if somebody lived in very close proximity to the trail but had to go a mile out of their way to actually get to the trail. The response was good call. The variation in access points makes a good case for buffers. Good job. I may have missed this part, but how far back in time will your data be collected since housing prices are in constant state of flux? So there's two ways to do the housing prices to keep them consistent. One is to have a limited time set and get actual sales data. The problem with that is that you lose, you may not have a big enough sample size. But in Fairfax County, they're required by law to have assessed values that's fair market value. So at any point in time, I can have a real estate assessed value for every single property, and it will be, even if the assessment process is incorrect, it should be incorrectly applied consistently across all houses.
Okay, great job. Yeah, Fred says thanks. So we will move on to our last presenter today is Adam Clark. So Adam, if you want to go ahead and start sharing whenever you're ready.
Excellent. Thank you very much. First, I'll do a mic check. How do I sound?
Loud and clear.
Thank you very much. Sharing my screen now.
Yep, we can see it.
Beautiful. Thank you very much. Well, good afternoon, everybody. My name is Adam Clark. Last presentation of the day, so there's quite a few great ones out there. I'm going to hope that meeting those benchmarks. To start, I would like to say thank you very much to Jarlath O'Neill Dunn for serving as my advisor during this capstone experience. Today, I am presenting my Geography 596 Alpha capstone project proposal titled Center Pivot Irrigation Feature Extraction in the Chesapeake Bay Watershed using an object-based image analysis approach. Irrigation in the United States is a very large and plays a very vital role in agriculture. The 2018 Water Management Survey, which is a former product put on by the USDA National Agricultural Statistics Service, which is the former Farm and Ranch Irrigation Survey. They have some numbers that they put out here in 2018, indicating that the total United States acres and farms were just over 222 million, with about roughly 25% or approximately 56 million of those acres were irrigated. Center pivot irrigation systems are an increasingly popular method of agriculture irrigation, not just in this region, but throughout the United States. And the focus of ag producers and conservationists in regions such as the Chesapeake Bay watershed. Therefore, geographically locating and understanding the spatial distributions of CPI systems offers many benefits, such as agricultural monitoring and yield estimates, environmental stewardship, sustainable agricultural practices, and natural resource management and conservation. These issues are addressed by employing an object-based image analysis approach to center pivot irrigation feature extraction using LiDAR data and multispectral imagery, and really focusing on the elements of interpretation and contextual development. The Chesapeake Bay watershed is the largest estuary in the North American continent, sprawling approximately 64,000 square miles, with vast and complex ecological, cultural, recreational, and historic significance. As you can see, it includes New York, Pennsylvania, Maryland, Delaware, West Virginia, and Virginia. And it is believed that approximately 30% of this vast region is utilized for agricultural purposes. And also believe that it aids in excess nutrients and sediments affecting water system health. The sheer size of this watershed, as you can see, and the intricacies of the ecosystems within continue to draw quite a bit of attention from both Bay supporters and agricultural producers. with interests such as, ranging from poor irrigating practices, which push pollution and soil into tributaries in the bay, to the other side of the house, to consistent crop production in wide weather conditions, which is essential to all people. Center pivot irrigation is one such irrigation system which is used in the region and consists of above ground infrastructure that is anchored at or near the central portion of an agricultural field, allowing for the system to irrigate crops below while oscillating around. A review of center pivot irrigation identification research in which remote sense technologies were employed, I found that it revealed 3 methods that have been applied by researchers. The first is visual interpretation and digitizing. The second is pixel-based classifications. And the third would be a usage of convolutional neural networks, CNNs, in those various architectures. The U.S. Geological Survey, the USGS, and the University of Delaware Extension sought to geographically locate these systems and created a data set which identifies center pivot irrigation system locations and agricultural field extents deemed benefiting from such technology throughout the North Atlantic coastal plain. They used a variety of orthophotography and satellite imagery, and they manually digitize upwards of 5,438 locations throughout the study area. While these methods were effective in identifying and mapping of center pivot irrigation systems, like anything else, it's manual. The manual interpretation process is laborious and requires many input resources to undertake and complete. This image highlights the center pivot irrigation signatures, such as the piping, or we'll call them irrigation arms as well, pumps, well houses, wheel tracks, and access lanes. Interpretation of these signatures assisted in the polygon data digitization, representing the agricultural field extents associated with the systems, as well as the systems themselves. An alternative approach to the manual interpretation process is a pixel-based classification. The pixel-based approach focuses only on the spectral values of the individual pixels during the classification process. Environmental Systems Research Institute, ESRI, offers 2 varieties of that pixel-based classification process. The first is supervised classification, which utilizes user-determined categories based on the range of spectral values. The second is an unsupervised classification, in which this software itself decides which categories will be developed based on the statistical differences in the pixel values. The images in the slide are representative of a classification approach using an ESRI example. The upper left is a 4-band Landsat thematic mapper image of the northern portion of Cincinnati, Ohio. The middle image is showcasing 5 land use classes that were defined from the classification process. And the lower right image represents the final output of land cover classification after the training samples were evaluated. Although the pixel-based classifications have been, historically utilized in remote sensing workflows to classify data, there are quite a few drawbacks to using these approaches. The supervised pixel classification methods require prior knowledge and predetermined categories for consistent and accurate classification. And on many occasions, those types of user defined values and ranges are not transferable to other regions, and must be altered like that. Further, the pixel-based approaches struggle to generate meaningful image objects, along with misclassification of water and shadows, and that's due in part due to lower reflectance values. Recently, convolutional neural network, CNN-based approaches have been coming into to light. And the CNN approach is a form of deep learning that is used in image recognition and object detection. It's been used pretty extensively. This is an example of a study that sought to assess the usage of the CNN-based approach. Again, it's a deep semantic segmentation process of algorithms to automate the identification of the center pivot irrigation systems in Brazil using Landsat 8 satellite imagery from 2014 as the training and the validation data. And they later subjected Landsat imagery from 2018 to 19 to various CNN architectures. The researchers noted in this study that classification errors existed and were associated with any rainy season imagery and were due to spectral similarities, homogeneity within the surroundings. Whereas the errors associated with critically dry season were due to spectral similarities between like a harvest and tillage practice relative to dry vegetation. As you can see in both images from the study, when you compare the ground truth to each season, there's inconsistencies, due to seasonal change in moisture. This is an example of a study that sought to employ a method of automated detection and mapping of center pivot irrigation systems in Brazil. They subjected a 4-band multispectral imagery to a CNN architecture called UNet. The outcome of this, researchers, it appeared that they achieved their goals, but noted errors and high variability in textural and spectral values. Difficulty with irregular shaped fields, faint and non-consistent field boundaries, and inclusion caused by curved roads. And I think this image kind of captures that as well. In this particular case, an approach was employed using an object-based image analysis approach methodology called the canny edge detection watershed segmentation. To automatically identify and delineate agricultural fields in South Africa using Sentinel-2 satellite imagery from 2017 to 2018. They used a 5-step approach to accomplish their goals in edge detection and edge layer aggregation. So after they performed all of the detection, they aggregated their edge layer. They performed a segmentation on this edge layer aggregation and utilized Trimble's decognition software, did a cultivated field extraction and a noise removal process. And although the study appeared to achieve the goals of the research by improving an existing OBIA approach to the field boundary delineation, it was noted that both the supervised pixel-based approach, as seen in yellow, and the canny edge detection and watershed segmentation OBIA approach, as seen in green, experienced difficulties in delineating adjacent fields with relatively high homogeneity. And we can see that in the left column, if you will, viewing those red circles and how that how the outcome presented itself in the pixel-based and object-based approaches. This approach the researchers employed an object-based image analysis approach to land cover classification using 4-band 1 meter USDA NAPE orthophotography and 1.5 meter DEM, DSM, and NDSM. And this is in part as an alternative to a pixel-based macro scale land use land cover data set the researchers were not quite happy with to be used in finer scales. So they subjected this the 4-band NAPE imagery to principal component analysis in order to derive 3 new bands. The Trimble's OBIS software was used to perform simple segmentations and classifications. In this image, the first row represents imagery used. The second row represents pixel-based classification results, and the third row represents the OBIA approach. Although Although the researchers achieved the goals of the objectives here, I found that there were numerous questionable areas in the methodology. So the researchers used the multi-threshold and quad tree segmentation algorithms to strike an equilibrium between computational time and product accuracy. And at the very same time acknowledged a different segmentation method called multi-resolution as a very effective method, but they chose not to utilize that due to processing time. I found that a little bit contradictory due to the main goal of this was to develop this land use land cover data set for use in finer resolution. Further, the research team used LiDAR data collected in 2005, and they used their multispectral imagery from the USDA NAEP imagery from 2010. And so the collection year inconsistencies created quite a bit of issues with elevated objects in one data set, but not present in the other due to the time gap between acquisitions. So at this point, what are we doing here with this process? Where do we go from here? The issues and weaknesses and gaps noted in the prior research, they're addressed using an object-based image analysis approach to feature extraction. The OBIA method moves beyond traditional pixel-based classification by identifying and classifying image segments based on elements of image interpretation, such as, but not limited to context, shape, texture, topography. And that's to give a better representation of the Earth's surface. This study seeks to employ an object-based image analysis approach to center pivot irrigation system feature extraction in the Chesapeake Bay watershed. And we'll rely on eCognition OBIA software and publicly available data sources such as the USDA NAEP multispectral imagery and available high resolution LiDAR data. The study area includes 5 pilot sites in Delaware, featuring high variability in spectral and textural values, adjacent fields with relatively high homogeneity, CPI signatures such as piping, irrigation arm pumps, well houses and wheel tracks, irregular shaped fields, and high variability in adjacent fields. As seen here, pilot area 1 showcases high variability in spectral and textural values. This shot here, pilot site 2 showcases the adjacent fields with relative high homogeneity. So in this case, we're looking at we'll use those CPI signatures we've learned about in the past couple of slides, and we'll make use of another interpretation here using association. We can associate the adjacent wheel tracks. They're indicating separate structures, separate irrigation structures, and so we can also note then that that's a separate field, and where it's also how similar the spectral and textual values are. In pilot site 3, it showcases the CPI signatures we've talked about, such as the piping or the irrigation arms, pumps, well houses, and wheel tracks themselves. Pilot site 4 showcases irregular shaped fields. As we can see, we've got a half moon shaped product there in the center, a field that's kind of split by an access lane. And we've got 2 triangular shaped fields, and all 4, if you want to call it that, are examples of where, center pivot irrigation systems are, being subjected to the field. And pilot site 5 showcases the high variability in adjacent field sizes. In this case, we've got a very large, shooting off the hip, this could be a quarter section sized field being subjected to quite large infrastructure. And on the lower left, we've got a couple of smaller adjacent fields, so quite a large difference. Here's we'll take a look at the data. At the left, we've got 2013 USDA NAEP imagery that's seen. This imagery is captured during the leaf-off growing season with spatial resolution ranging from 50 centimeters to 2 meters. In this case, this is a 1 meter product here, and the spatial resolution, it's typically a 4-band spectral resolution products. We're talking about 4 bands: red, green, blue, and near infrared. The middle represents a DEM, digital elevation model, and the right represents a digital surface model, DSM. Both the DEM and the DSM are LiDAR derivatives from the 2014 USGS Hurricane Sandy supplement for Maryland and Delaware. And this was a LiDAR collection project. And this LiDAR capture was leaf off, as typical terrestrial LiDAR captures are, and was collected from 12/17/2013 through April 6 of 2014. This is a quality level 2 product which meets or exceeds the USGS base specifications 1.2. In this case, the University of Vermont Spatial Analysis Laboratory, UVM-SAL, graciously provided the pre-processed 2013 USDA NAEP imagery and both of the LiDAR derivatives. This was greatly appreciated. This allows my work to concentrate on feature extraction. This study relies on OBIA software, for segmentation, data fusion, classification, and creation of vector outputs. In addition, ESRI's ArcGIS Pro software will be used for data exploration and the entire portion of the accuracy assessment process. The USDA NAEP orthophotography mosaic, along with all the LiDAR derivatives, will be imported into an eCognition project. The LiDAR derivatives, the DEM, DSM, and a normalized digital surface model, the NDSM, they're proven valuable in discriminating elevated objects and are pretty critical for the proposed work. A feature extraction rule set will be created focusing on the elements of interpretation, such as tone, color, texture, pattern, shape, size, location, and association. And that is credited to Charles Olson here in 1960. And I'll be segmenting, identifying, classifying, and extracting individual groups of image objects across a study area using a rule set. Although the focus of this plan is automating CPI feature extraction, additional features will be extracted along the way. Analysis of methods here. I plan to explore, I expect the eCognition rule set to include, but not be limited to, the following collection of algorithms and calculations. I'll be doing an NDSM layer calculation, imagery brightness, normalized difference vegetation index, and NDVI. Multi-resolution segmentation will be my primary segmentation approach. Assign class, merge region, removing of classifications, and exporting raster and vector files. The output raster and vector data set will represent the final classification of the rule set. As seen in the left image, the multi-resolution segmentation parameter window is open, and then to the right image is an example of a multi-resolution segmentation output. Last, the output raster will be subjected to a robust accuracy assessment using ArcGIS Pro's accuracy assessment points. We'll be using an equalized stratified random and a stratified random sampling scheme. And I expect to generate 50 samples per classification at minimum, and we'll increase that to meet Galton's recommendations if needed. I'll be evaluating each point from what I visually interpret the correct classification to be. And finally, I'll be computing a confusion matrix, which will output an Excel file, which highlighting errors of omission, commission, kappa, and overall accuracy between the classified raster and the reference imagery. Challenges I look here. I look at with the identification of the infrastructure seems pretty straightforward. There's actually quite a few challenges. Imagery capture is, in this case, USDA NAEP is captured during peak growing season, whereas the terrestrial LiDAR capture is typically captured during leaf off. And in this case, I've got the left data frame clearly reveals CPI infrastructure and associated signatures in the multispectral imagery. And we want to take a note at the location of the infrastructure and the irrigation arm in particular. And then the right data frame shows the NDSM. This is, again, this is a representation of the height of all above ground features and looking at the movement of that arm. the circular signatures in some of these fields as well are a factor. There are many instances in which irregular shaped fields are benefiting from the infrastructure, and we've already discussed, and which is representative in the pilot sites, but faint field boundaries, interfield and intrafield variabilities, and spectral and textural values. And this really gets to the bottom of, I have to focus pretty strongly on the elements of interpretation and building context within that rule set. That would be an evolving process. The workflow diagram that's been pretty discussed in detail here. Input data and development of an output rule set, which then creates classified image objects and outputting into a raster and vector format. This classification process, I currently just kind of mapped out 5 classifications: water, structure, trees, agricultural fields, and the infrastructure themselves. But there's going to be numerous temporary classes, and I expect this output classification to evolve along with the rule set. Timelines: defining a problem, proposing a project from October to December of this year. Data acquisition, I had that slated for December of this year, which that's already complete. Again, thank you very much, UVM Sal. The feature extraction, development, and execution will take place this month, and I hope to have that completed by March of 2021. Accuracy assessment, I would like that taken care of as well in March of 21. Creating the final report, I have that slated for April 21. Submitting the abstract to a conference, April of 21, and present at a conference the April and more than the May timeframe. Here's a list of my references. With that, that is all I have at this time, and I'd be happy to address any questions if there are any.
Any questions for Adam? No, our numbers are a little bit down. It's been a long day, but great job, Adam. This looks very interesting.
Yeah, thank you very much. I hope I did not put anybody to sleep. That may have happened. It is lunchtime as well.
I don't think so. I think some of the numbers, people probably couldn't stay for a full 2.5 hours, and but no, it is interesting, and I look forward to seeing how this project plays out. Well, in case anybody else is still typing a question, I'll just remind everybody about the peer review form. I'm going to put that into the chat real quick here. So just please fill that out for the presenters today if you can. I know everybody in 596A does have particular students to review. I think each person has 10 to review, and that information can be found in the email that I sent. But yeah, it looks like maybe some people will email you with questions, Adam. Fair
enough. Well, I really appreciate your time. Thank you very much, everybody.
Yep, great job, everybody. Thanks for sticking in here. This is the last one of this semester, so until spring 1, we'll have another set of presentations. And as a lot of people mentioned today, we will be having another round of 596B presentations in time for a May graduation. So that will happen, because it doesn't look like conferences will be back up and running at in normal capacity anyway. So we will definitely make that option available here. So we'll have some of those in the spring as well. Okay, thanks everybody. Have a good rest of your day.